final part of the setup within the load frame is to clamp the cell down to the base using these adjustable clamping bars. These bars will ensure the triaxial cell stay in the load frame during any dynamic or fast loading tests. If this was a real sample, we would of course run a saturation, a consolidation, before we can run the dynamic test. Actually, with this, what I'm going to do is quickly get it to a state where we have some load on the sample and we have cell pressure and a back pressure, even though it is only to this valve. So what I want to do first is dock the sample. To dock the sample, or rather bring the load cell in contact with the top of the specimen, one method is to set a load target. The ELDYN machine is very sensitive, so we can set quite a small load target, watch it move, and when it touches the sample it will stop. So maybe 10 newtons, I'm going to set 0.01 kilonewtons and watch the actuator move. I can see it has about 10 millimeters to go before it will be docked. Docking process is about to complete. I can see there's about half a millimeter, no millimeters, so it's stopped. It's found the 10 newtons that it was looking for and is now perfectly docked. Now we have a cell pressure of 100 kPa and just a very small 10 newtons bedding load of the load cell. I'm going to set up a test, assuming that you're reasonably familiar with GDS Lab, and I'm going to run an advanced loading test where I'm going to keep the cell pressure constant at 100. I'm going to increase the back pressure just slightly, and I'm going to ramp the load cell value up to 1 kilonewton in 4 minutes, just so that it gives us a starting position for doing a dynamic test. We'll do a dynamic test around 1 kilonewton load. So if we focus now on the computer, we've come to the end of that test now. So we have 1 kilonewton on the load cell and 100 kPa on the cell pressure. I'm going to pause the test, and then to make this demonstration easier, I'm going to go to the object display and set the displacement reading to 0. We'll just make running the dynamic test a little bit easier if we're running it around a datum of 0. Now I add another test, a dynamic loading, displacement control. For starters, we'll do a 1 Hertz test. The datum, it's common to put the datum exactly the same, or as close as possible to the existing datum, which we can see on the screen in front of us. So I'm going to select 0. Let's choose an amplitude of 2 millimeters, which will mean around a 0 datum, the dynamic test will run at +2 millimeters and then down to -2 millimeters. And we'll keep the cell pressure at 100 kPa, the same value that it currently is. On the next screen, we can see we can have some options for the back pressure controller. We can choose an undrained test, so we can choose to just hold the volume on the back pressure, and maybe we'll close the valve on the back pressure as well. Or we can choose a drained dynamic test by attempting to hold a back pressure value which we can enter into the software. We can select the number of cycles, let's choose 10, and the number of cycles on and the number of cycles on. If the number of cycles on are more than the number of cycles, then of course we will retrieve all of those 10 cycles that we're going to run. The number of points per cycle is the data points we're going to collect for the cycle. It will not affect the control at all. It is just the points that we're going to acquire. And I'm going to leave it at hold pressures at the end of the test and wait for user interaction, which means the test stage will pause. Even if we've got another test stage set up, it will pause and wait for the user to say move to the next stage. Add that to the test list, go to the test list, choose go to test and start test. Now the test will be quite quick, of course. We'll see 1 Hertz. Immediately we see the real-time display appear, and GDS Lab is keeping up with sucking the data from the DCS box. So the test is actually finished. When all the data has been recovered, the real-time display will close and we can review the data. Okay, so let's step it up a bit and show that the machine can do 5 Hertz, and we'll do a similar test, displacement control, but this time with 5 Hertz, 2 millimeters amplitude again. So create new test, dynamic cyclic displacement. I'll choose 5 Hertz for the frequency. The datum we'll leave at 0 millimeters. Amplitude 2 as before. Set the cell pressure. Because the test will be 5 cycles a second, it will be over quite quick, so let's have a look at 25 cycles just so we have something to really see. I'll say go to test and next stage, and let's take a close look at the actual actuator. Here we go. The real-time graph shows excellent sine wave and perfectly achieved plus or minus 2 millimeters. If we zoom into the graph, and the load changed by about plus or minus half a kilonewton. So that gives us a good guide for the next test we'll do, which is a load control test.